Good afternoon. Welcome to the Mechanical Engineering Department Senior Capstone Design Program final presentations for spring 2019. The next team to present is a combined team of 3 teams, started as 2, and we combined into 1, divided them into 3 for better management. They competed in the Air Force Research Lab University Design Challenge. This is their 8th year participating in that. They were down in Florida, most of them. It was horrible down there. And they did a fantastic job representing the university, the program, and the department. So with that, I'm going to turn it over to teams 1, 2, and 22.
Did you know in the last 17 years, there have been over 2,200 casualties from active shooters? From 2001 to 2017, there was an increase of 1,500%. This is one reason why the Air Force Research Lab tasked us with creating a solution to help first responders locate victims and or the threat in active threat situations. This includes, but does not limit to, active shooters, hostage situations, bomb threat, and natural disasters. Michigan Tech decided to focus on active shooter, and with that, I present to you Marco Polo. I'm Olivia Smith, and these are my teammates.
I'm Kevin Mielbeck.
I'm Aaron Escola.
Quinn Kastriak. Zach Kondrowski. Alex Stowell. Jordan Kilteka.
Rebecca Spencer.
Riley McMichael. Justin Nemi.
Thomas Richards.
Ryan Washington.
Now today we will introduce the solution of Marco Polo. We will walk you through our supporting engineering. We will talk to you about our testing and verification and tell you about Marco Polo's future. Now to begin, the Air Force Research Lab, in order to create unique ideas and design solutions, they did not give us any requirements or constraints. But instead they wanted us to talk to subject matter experts to get their input on solutions that would be useful to them in the field. We talked to many different types of subject matter experts, one being Captain Van Gelly. He was the first responder that led the first entrance team to the Sandy Hook shooting. We learned from him that in 5 minutes, 26 people were killed, making us realize that every minute matters in these situations. First responders don't have the time to wait around when they arrive on site. They're running into the building as soon as they can, so it's important to get them as much information before they arrive on site. Ideally, Captain Van Gelly would like to be led directly to the shooter or threat. We also talked to John Stone. He is here local in Houghton. He is the regional coordinator of Michigan's Healthcare Coalition, and he specializes in firefighting, hazmat, and EMS. We learned from him that small towns like Houghton don't have the budget to afford the high-tech, expensive equipment that big cities can afford. So creating a solution that is inexpensive and affordable to everyone is very important. Now, active threats covers many different topics, and so we chose to focus our initial design on active shooters. But Marco Polo has since been expanded to help in natural disasters such as hurricane search and rescue, and alerting first responders if there are any hazardous environments that they need to prepare for before entering the building. Now we are about to show you a video of how Marco Polo works in an active shooter scenario. There are 3 things you need to know before watching this video. First, that Marco is a tracked vehicle system that has been pre-placed in Michigan Tech buildings. This acts as a first responder that's ready to be activated at any point. It is remotely controlled. Then there are 2 applications, one for civilians. All students have downloaded this at the beginning of the school year. It detects gunshots and sends their location to the first responder. And finally, the responder application. This shows the locations of all civilians, first responders, and Marcos with the application, and alerts the first responder if there are any threats that have been detected on in the building. This is shown on a cell phone and is attached to their wrist for hands-free operation. Here's the video.
All right, so before we get started, for your safety here at Michigan Tech, in order to connect to the Wi-Fi, we're going to have you download the Marco Polo application. So go ahead and do that if you haven't done so already. There are 25 different species, primarily in North America, is that there's actually only one species of chipmunk that is outside of North America. That's the Siberian.
your emergency?
We're hearing gunshots on the first floor of Fisher. Please send help. We're on Michigan Tech's campus.
I'm sending the police to your location.
We have an active shooter at Michigan Tech campus, Fisher Hall, address 1400 Townsend Drive.
Carl, activate Marco Polo.
All right, I'm on it.
Marco has eyes on the shooter.
Now that you've seen the scenario, we're going to talk to you about some of the supporting engineering details of our solution. As Olivia stated, the Air Force Research Labs didn't give us any specific requirements or constraints, so we relied on subject matter expert feedback to drive our design criteria. The most important feedback we received was that our solution should be simple and effective in locating a shooter in a building while not compromising a first responder's awareness and response protocol. These engineering decisions are highlighted in our system-level solutions. We'll start with the control center. Incident Command will be running the Marco Polo website to control Marco as well as you monitor the Polo application. You can see the Marco controller in the screen on the left and the Polo application in the screen on the right. We'll start by talking about Marco and we'll get back to the details of Polo later. By designing Marco as an Internet of Things device, it gave it the unique ability to be controlled from any location by an operator through this website. We decided to use a grid mapping controller to eliminate jerky movements of Marco and allow for dynamic control of its speed, of its motors. Using the live stream video, the operator has the ability to drive Marco as well as view his surroundings and alert the first responder of any hazardous or threats that were in the surroundings that Marco can see. Using the bottom right portion of this screen, the sensor outputs from Marco are read onto the website, giving the operator the ability to alert a first responder of any hazardous environments they may be aware of when entering a scenario.
Here's a closer look at Marco. The chassis of Marco was purchased as an off-the-shelf kit. Marco contains a camera as well as sensor suite that provides the pilot at Incident Command with eyes, ears, and nose inside of the building. The sensor suite is fully customizable, but currently contains a combustible gas, carbon monoxide, smoke, and O2 sensor. On the left, you can see the two electronic speed controllers as well as the Arduino on the Marco device. Marco is powered by two 5,000 milliamp hour batteries that are connected in series and output in parallel to the two electronic speed controllers. This power is relayed to the Arduino, which then powers the gas sensors as well as the fans on the device. As Aaron mentioned before, the controller on Marco is on a web page which sends information through the phone to the Arduino and then to the electronic speed controllers. Now that you have seen what Marco looks like, here are some short clips of how it can be used. Video on the left shows Marco entering a room, rounding the corner, and spotting an active threat, in this case, myself. On the right is an outdoor scenario, how Marco can be used in search and rescue in the case of an active disaster. In this case, the civilian's phone was activated using the Polo application and led Marco to this location.
As we go back to incident command, you can see the Polo screen on the right. What the Polo screen shows is an active mapping of all civilian applications, same as what's on the wrist-mounted system of the first responder. This is Wadsworth Hall, and what's important to note about the marking is that each marker is color-coded. Green represents a civilian that has activated the Polo application. Blue represents the location of a first responder. Purple, which is not shown here, would be the location of Marco, who's already on site. When a gunshot is detected, it places a red marker at the current location of the cell phone. After 30 seconds, this marker would turn to orange, and then after a minute, this would turn to yellow. This would allow the first responder to follow a trajectory of the active shooter throughout the building. We could also modify this color coding system to represent something different in a natural disaster, such as severity of injury or whether or not somebody has been assisted. The goal of our Polo application was to eliminate 50% of the building for an active shooter to have to search. What you see here is Fisher Hall and a police officer responding to an active shooter in Fisher Hall. Originally, he was notified by dispatch that the shooter was in Fisher Hall. When he enters the building, he would have to go left or right down the hall. Given the old information, he would be heading towards the east side of the building into Fisher Hall. But with our application, he knows that the shooter has since moved from that location and is now in Recce Hall. Had he gone right to the last known location, he would have to rely on his instincts and eyewitnesses to determine where the shooter currently was. But with our Polo application, he can go directly to the shooter's last known location. So to determine whether or not the Polo civilian application has heard a gunshot, we use the cell phone microphone, and we use a fast Fourier transform within that. So what happens with it is every sound wave is made up of frequencies and powers at those frequencies. Fast Fourier transform or FFT can break down a sound wave into those frequencies so we can analyze it. We do this in two parts. First, we analyze the cell phone microphone voltage, and we determine a threshold in testing at which we want to investigate a sound because it's suspicious and might be a gunshot. Once we perform the FFT, we also look at another threshold that we determine in testing. If it passes that threshold, it's considered a gunshot, and that information is forwarded to our central hub. Another thing that's important to note is that we would have to come up with new thresholds given the building that we're in or the environment that the Polo application was deployed in. So here's an example of how the central hub fits into everything. The civilian application forwards the location and whether or not it heard a gunshot to a central server. In our case, we used a Google-based Firebase server. This location can then be read by the first responders. You can also see that Marco's location and sensor and motor control information is also controlled throughout this central server, and Incident Command can also view this information.
Moving into prototype verification. So as Aaron noted on slide 9, Marco was able to meet many of our design requirements that we came up with on input from subject matter experts. So while we were assembling Marco, we came up with different test plans on how to verify that we would meet these design requirements. One of these tests was we went up to the SDC and had our operator more than 250 feet away from Marco and drove it until the duration of the batteries would die. This verified that we were able to control Marco from over 250 feet and that the Marco would last for over an hour. One of the refinements that we made for Marco during this testing was when we were testing, we noticed that the network latency for our YouTube live streamer was over 4 seconds. And we changed this to Skype, and our network latency moved to below half of a second. Our final test for Marco was during our presentation for the AFRL in Florida. We had one of our team members, Jordan, driving Marco onto the stage during the beginning of our presentation while he was up here in Houghton. That's over 1,300 miles away. One of our unmet requirements for Marco was that we were unable to calibrate the sensors.
For the Polo application, we had to test whether or not the gunshot could correctly classify a gunshot using the FFT. We did this using a 9mm in the volunteer firehouse. So that's a member of our team, and the cell phone is within a 15-foot radius, and he fires several blank shots, and you can see based on the left that it was able to detect a gunshot. In order to accomplish this, we had to lower the threshold based on the fact that blank rounds are quieter than live rounds. This goes back to what I was saying. Depending on the environment, you would likely have to test and modify the threshold before you deployed the Polo application. To test the complete system, we played Marco Polo within Fisher Hall. We took one of the team members with a civilian application and had him go to a certain part of the building. We then gave another team member the first responder app and sent him out to go find him. We repeated this process with Marco and had somebody there driving them through incident command. We were able to narrow down the location of the person who went and hid to 4 rooms, which is above our goal of 50% of the building.
We take the privacy of our users very seriously, and data security is at the forefront of each of our design choices. And our goal is to create an ethical solution that users can trust by being straightforward with the data that we collect. Our solution, we provide a third-party platform that creates an appropriate security buffer between first responders and civilians. The Polo civilian application collects location and gunshot data from the users, both of which are only accessible to local law enforcement during an emergency situation. While the Polo civilian application utilizes the civilian's microphone to determine gunshot profiles, the audio files are processed within the application and never leave the phone. We decided to conduct a survey to see how individuals feel about third party having access to certain sets of their information. And our survey included over 600 individuals, including students and faculty from Michigan Tech, as well as people reached out to via social media. And our survey concluded that over 70% of the individuals surveyed were willing to provide the access to their information necessary for Polo to save lives. And while we're really proud of our Marco Polo solution, we see the opportunity for continuous improvement upon our idea. And these improvements are a result of our own individual research as well as input from our subject matter experts. These include hardware changes to Marco, one of which is to create a more secure and efficient communication system, a two-way communication system on the Marco device to allow first responders to more effectively contact individuals in an emergency situation. This also includes the addition of sirens to Marco. We saw the opportunity for this improvement after learning that shooters typically self-terminate once they find out that law enforcement arrives on the scene. And finally, because Marco lowers the cost of entry for robotic monitoring systems, we see the opportunity for multi-level Marco coverage by installing a Marco device on every floor of a building as frequently as of every fire extinguisher that you might see.
Now, moving on to the future of Polo, we would like to expand this to iOS systems for Apple devices, as well as make it downloadable for all laptops and tablets. Currently, most elementary schools and high schools use Google Chromebook, which is able to download the civilian application right now. Since allowing to have more ears inside the building of schools that may not have cell phones, such as young students. We would also like to create a database of all the Wi-Fi access points. This would allow us to expand to multi-level floors. If you have a database, assign the IP address of the Wi-Fi access point with the floor, we would be able to pull that information from the cell phone and determine if they're on the first floor or the third floor. We would also like to implement an after-action injury report. This would allow first responders to know if a civilian is injured, if they're safe, if they need help, anything like this. This would be through buttons that they are able to press on the civilian application. You would then show up on the first responder map with a given color-coordinated system. Now, the creation of Marco Polo took a lot of work. First, we would like to thank the Air Force Research Lab for giving us this opportunity and helping us throughout this process. Having such a unique process has been a great experience, and we are all happy to be a part of it. We'd also like to thank all the MTU advisors and faculty that have helped us throughout this entire process. We wouldn't have been able to get to the end product without your help. And thank you to our subject matter experts for all your feedback. The platform of Marco Polo has huge potential to be implemented for the safety and security of all schools and businesses across the world. In the high-stake, fast-paced environment of active shooters, saving minutes saves lives. We will now open it up for any questions and discussions.
Questions? What happens if I have the app installed on my phone and I go to the shooting range, the SDC? And I guess the broader question is, how are you rejecting false positives?
So with our application, it's only activated in an emergency situation. So an example would be 911 has to be contacted before we turn on the phones to be listening. In such case, 911, there's an active shooter on Michigan Tech campus. We then, through our server, activate the cell phone. So to answer your question, if you were at the range, the only way your phone would be listening is if there was an active threat at Michigan Tech.
Right.
So will it pick up a silent weapon?
So that's something we haven't really dived into. That would take more work with fast Fourier transform and analyzing a gunshot profile. And there might be another method that we would prefer to use within the cell phone. Fast Fourier transform is just what we chose to for the purpose of this project, but that might not be the best way to go about it.
Are there other hazards that you, so I know you listed off a variety of different, I think it was like carbon dioxide, oxygen levels. What other hazards have you thought about?
Sensors. Yeah, so it's carbon monoxide, combustible gas, O2, and smoke detector. So the idea behind the sensor suite is it can be customized for specific use. Those were selected just for proof of concept to show how they react when exposed to that gas.
So one of the things we had in mind during this entire process is that this is a problem we came up with a solution to that goes beyond what we were able to do here at Michigan Tech. And so coming up with this concept that you could, Marco is a transportation device. It could be any type of vehicle, like if it's a drone or anything like that. So you could implement a variety of different sensors and things like that, even like thermal imaging and other things like that. And so we just really wanted to focused on things that were within our reach for the scope of this project, but we do see the potential for a vast improvement on this platform.
So if there was a hazard, then through the system it alerts the law enforcement that there's
Yes, so through our central hub, our Firebase server, these sensor outputs are read back to the incident command website, which then alert an operator. They would have direct contact with a first responder. So if there was a case of carbon monoxide or a gas leak and a first responder was responding to a situation, that would be displayed on our sensor readout, and they would be able to tell there's a gas leak here where Marco is, avoid that location. It's read back to the website, and this design choice was made so that you're not reading it directly to a first responder so they can focus on what they got to do while the incident command operator is at a remote location. They are not in the stressful scenario. They can read out everything and alert the first responder if anything happens and they need to know about it.
So you said 30% of the people weren't comfortable sharing their phone or whatever?
Yeah.
Why?
So part of that was due to the way we asked the question. As has been seen in the news cycle a lot recently, there have been a lot of concerns with how very popular companies like Google and Facebook are dealing with an individual's data that is accessed on their phone. And so we ended up phrasing the question in a way that didn't help users understand what the data that they already are giving a lot of companies access to that they might not think off the top of their head. And so we actually, while we don't have any data other than what we collected, if we were to do the survey again, we expect with a little bit more clarity to see a far lower percentage of people who would not allow the use of the application.
It was also, we broke it down. We had them fill out their age group and then what they'd be willing to give up, whether it is location, microphone, both, or none. And we did see the trend that most of the people that said no were in the elderly population. They have the fear of Big Brother watching you, and so they weren't really giving that up. But the best is that we're worried about the masses. The majority of people in schools, businesses, the majority of people were willing. So.
And one thing to note on that for the future of pushing this product forward, something that we would like to explain to people while telling them about this is that each user generates an anonymous ID in the server. So you can't correlate a user's location to their name and their data. It's just an anonymous user. This is their location. They're a civilian. It keeps them anonymous, essentially.
Do you have the Command Center app on your flash drive?
We have the website that we can.
Download the website.
Yep.
So this is the website that we created for distribution of the application. So right now Olivia is going to the Incident Commander page, in which you can download any portions of the application that we've discussed throughout this presentation. There's directions and gives you an idea of what it needs and how it works.
So this would be, you'd have to download this to a local file currently. In the future, we would want it to be a generated URL, so it would be a website that you could access globally. Currently, it's something that you have to access locally, so you'd have to download all these files as well as our logo images for these things to pop up on the web page.
Is there a Firebase map?
Yeah, open up Firebase.
Yep.
So right now, with my cell phone, since it has both of the applications, I can open one up and say that there's an active shooter here, and it'll plot the location of my phone as well as the gunshot.
Here. This is a map, and you could zoom it into any scenario.
So that green dot represents my location.
This is our campus. And yep, this is where we're at in the meme here.
So if I now, this is the competition, this is the button we used for the competition, isn't actually the gunshot processor. So I can manually simulate a gunshot.
So that was.
And there's the red marker that will pop up.
I just turned mine on. One of those screens, and that's what's called the gunshot. There, I just shot.
That drops a red marker, but the civilian, it doesn't change the civilian's phone to a red marker. So the civilian could move to a different location, and the operator would still be able to see where the civilian was at. They just know that a gunshot was fired where that red marker was dropped.
There I am.
This location, some of the locations versus older phones, the GPS services aren't as accurate as they are in newer phones. So we bought a bunch of Walmart level phones, and their location services weren't nearly as good as the newer ones. So as technology improves and locations get better, this application will only improve.
Questions? Oh, you keep, we'll go ahead.
Well, for, let's say, elementary schools, we would just assume that all the teachers.
The teachers, and then also, like I said, the Google Chromebooks are computers that are in most elementary schools right now, and those are actually able to download the civilian app, so you can run it through that. So there wouldn't be.
Eventually, we would want to do all computers, not just so even this computer could be running it.
Keep Marco charged and on the ready.
So currently so how we demonstrate it is just place it in the building, but that's just a long-term goal to have it pre-placed. Don't really have a solution for that and how that would.
We talked about the idea of having these docking stations next to other things you would have, like your fire extinguishers, and it would basically be like a tamper-resistant little mini garage for the vehicle, and it would keep it charged and let it, and potentially even leave the sensors accessible to the open air to be able to act as your carbon monoxide detector. You might not need to have pre-installed things along, like that. So there's a lot of potential there.
And with that, we thought about the fact that fire extinguishers have to be tested every certain amount of time, every 6 months. So in that routine check, you could check the motors, check the sensors on the device, and you could do it all in one and make sure everything is working on it.
Consider armoring the vehicle at all?
We did talk about that, but one of the for the amount of time it was going to take away from other more important aspects of this project, we just kind of assumed that if a shooter is shooting at Marco, he's not shooting at somebody else. And so that was kind of our philosophy behind that.
You could also do, so the way the system works is you could just purchase, the school could just purchase Marco, and then you could eventually have different tiers of what they're looking for. And they could also just purchase the Polo application if they wanted, or they could do the whole thing and customize them as they thought their application needed.
Anything else? We've got a little time to know how long to leave for this one.
I got a question about your power on your robot vehicle. You said there's two 7,000 milliamp.
Two 5,000 milliamp.
5,000 batteries. How long does it work on that?
Approximately an hour. It was a little over an hour.
An hour 15, hour 20. But there's stops in between, so we wanted to say for now.
It doesn't seem very efficient, because I have a robot that we built that was more than 80 kilograms. Has had 6,000 milliamp hours, and it can operate for 45 minutes on just one battery. So I'm kind of curious how a much smaller robot would take twice the battery life.
Okay, I have one question regarding that. What type of battery technology did you choose to use on that robot?
That was lithium polymer.
Yeah, so for our robot, we chose to stick with nickel metal hydride batteries just due to the fact that they don't deteriorate over time as quickly. So the amount of performance that you achieved in your robot was obviously better because you're using a newer battery technology. However, that battery technology is less stable than nickel metal hydride batteries.
The storability was a key.
Yeah, so this thing is meant to lay dormant in like a building for like 6 months, but if you were used in polymer batteries, that the discharge rate for them would be too fast and they don't have that great of a storage shelf life. So the design decision to go with nickel metal hydride batteries was just a design decision to allow for storage ability in a building.
Also, the way that the phone is integrated with the Arduino, the batteries actually charge the phone at the same time. So that was another drain on our battery that wasn't just the motors of the battery. Further on the lithium or the LiPo battery, the nickel metal hydride batteries are a lot more stable. So if a lithium polymer battery gets punctured, it shoots flame out of it. And we wanted to go with a much safer, more stable battery platform.
Anything else?
Any key reflections? Looking back, would you have done something different now that you're at the end?
There was a couple of things that we had to do specifically for the competition. We would have invested more time. I would have liked to invest more time in the actual gunshot processor, using the FFT to do that, and maybe see how far we could really take that.
I think that, and like with regards to what Kevin's talking about, there's a lot of developed technology that exists today that is in different fields that would potentially like be able to be integrated into this. So like there are, I think we found out like 30 some odd different patents for different types of gunshot analysis. And so instead of coming up with our own, like there are a lot of experts in different fields who already have a lot of that really great information. And so we could find out what other technologies would be better implemented. There's just a lot of different specialized fields that could be applied to this that would improve it.
Talk to any victims as you were doing your research?
I think we had considered it, but then we had to kind of move forward with the design solution. We had considered it within like when we were creating like the problem statement in that portion, but just due to time, we didn't know if we would like how to reach out.
A lot of that was focusing on the active shooter. If we had to focus on injury reports or natural disasters, we would have reached out to more victims. So I think their input would have been valuable. But for the active shooter, we figured in a lot of protocols. The training that they give for protocols is what we focused on, just because we're right at the surface of it. We haven't dived into how deep you could really go with it.
And I think that one of the things we really kept really in the front of our minds is that when there's a shooting happening, people aren't going to be pulling out their phones. Everybody's taught to to run, hide, protect yourself. Those are things that, especially in such an adrenaline-infused situation, that people won't have to think about that. So focusing on the application from a user standpoint wasn't as high of a priority, because there's already plenty that people who are in that situation have to deal with.
How could this be used as is, or as you envision in something like a hurricane, tornado, earthquake scenario?
So in a natural disaster scenario, you could have it preparatory, so that if you knew a natural disaster such as a hurricane was going to strike an area, you could activate the applications before it happened, so that in the aftermath, you would have the locations or the last known locations of people. If you had your injury report in there, you could then prioritize who needed help the most, and you would have their locations. So it would vastly help search and rescue.
So if you guys talked about or looked into commercializing it, making a product?
Yeah, that's something that we've been looking into. We've been working with the Innovation Center, right, through the university, looking into potential patents, things along those lines. Also consideration into further research on this topic through the university. But we've also just talked about the potential options for commercializing it. Yeah.
And the idea behind commercializing it would be a third party, so that first responders and law enforcement would have access to it that the third party would grant them, so they could activate it and use it as they needed, but all of their actions would then be reviewed. So if they were activating our application in a point that was unnecessary or abusing it, we would revoke those privileges, and then that department would be held liable to their voter base or their local schools and stuff. That way it would keep the big brother sort of scenario out of it. We would maintain full control.
That is, if you trust companies more than your government.
True. That's correct.
All right, very good, thank you.